This is the Calculus Pre-Lecture Series. I'm Brandon Ashley, and this video will be on integration by parts. So before we talk about integration by parts, we first want to recall the product rule, which says if I want to take the derivative of a product of functions, it's going to look like the derivative of the first function times the second, plus the first function times the derivative of the second. So for example, if I want to calculate the derivative d by dx of the function x squared times cosine x, then it's going to look like d by dx of x squared times cosine x plus x squared times d by dx of cosine x. And we can calculate these derivatives. The first one's going to be 2x times cosine x. And then I know the derivative of cosine is minus sign, so I'm just going to write minus x squared times sine x. And that would be the derivative of that product of functions x squared times cosine x. And so one thing we want to do is try to invert this process. So we want to find a way of undoing the product rule, and that's going to be our integration by parts formula. So if I want to derive the integration by parts formula, I'm going to start with the product rule formula, and then I'm going to rearrange it a bit. So I'm going to get f of x times g prime of x is equal to d by dx of the product f of x times g of x minus, I'm going to take this function and move it over, so I'm going to have minus f prime of x times g of x. And I want to integrate this entire equation, so I'm going to get the integral of f of x g prime of x dx is equal to the integral of d by dx of the product f of x times g of x all times dx minus the integral of f prime of x g of x dx. Then by the fundamental theorem of calculus, the integral of the derivative is just going to give the argument inside, so we'll be left with f of x times g of x minus, this piece is going to stay the same, so I'll have the integral of f prime of x times g of x dx. And we want to clean up this formula a little bit, so I'm going to make the substitution u equal to f of x and v equal to g of x. And if I do this, then du is going to become f prime of x dx, and dv is going to be g prime of x dx. And if I make these substitutions, I can rewrite this formula as the integral of f of x is just u, so the integral of u, and g prime dx is just dv. So I get the integral of u dv is equal to f times g is just u times v now, so I get uv minus the integral of v du. And this is commonly known as the integration by parts formula. Okay, so now we want to try to calculate the integral of this product using the integration by parts formula, which I will write again as the integral of u dv is equal to uv minus the integral of v du. And if we want to use this formula, we need to choose, so choose u and a dv for our integral. And so we'll set this up. We'll have u is equal to something, which we're going to choose, and dv, I'll write down here, it's going to be the other piece we choose. And so sometimes it's a little tricky to pick these, but we're going to let u be equal to x and dv be equal to the remaining piece, cosine x dx. So we see these pieces sitting here. This is our dv piece, and this is the u piece. And if we do this, we can calculate du for our formula. Du is just going to be the derivative of x, which is 1 times dx, or you could just write dx. And then v is going to be the antiderivative of cosine, which is just sine x. So once we have our u, v, du, and dv, we can plug into our formula. And so we're going to get the integral of x cosine x dx is equal to u times v is just x times sine x minus the integral of v du, which is just sine x times dx. And then we can integrate this piece, so we'll get x sine x is the same, and the integral of sine x is just minus cosine x, so it's going to become plus cosine x plus a constant of integration c, and that will be our answer.